Okay, so let's take a look at a slightly harder factoring set. And it has to do with really looking for one of those first steps to factoring a quadratic is always to try to do whatever we can to make the problem more simple. And that has to do with making the numbers ultimately that you're dealing with smaller. And that's looking for the greatest common factor. So I have a couple of problems here. When I look at this thing, the first thing that I would notice is when I look at this number, like, if I did a diamond on this problem immediately, I have fairly large numbers like 180 and 27. Those are big numbers. So and those always make the problems much more difficult when the numbers are kind of big. So what I would really encourage you to do is look for greatest common factor, because what we're trying to do is break them down into the smallest parts anyway. So when I look at this problem, the first thing that I notice is every one of these pieces is specifically divisible by 3. So that means if I divide each by 3, and remember when we say factor, what we're really doing is dividing it into pieces. And so if I divide the 3 out, I would get just x squared because I divided the 3. I divided 27 by 3, and I divided 60 by 3. And now if you'll notice, those numbers are much easier to deal with. And that 3 is still part of my story. It's just sitting in front of it. And so I don't need to process it as I go. So now it looks almost like A is 1 in this story. So remember, on our diamond problems, we do A times C. So remember, A times C, A is 1 and C is 20. So that's going to be 20. The bottom number is B. And so we got a 5 and a 4. And remember, anytime you have a problem where the quadratic portion, this portion right here has an A equals 1, we could jump right to the story and do that. And that means this expression and this expression are in fact equivalent. And so one of the things that I mentioned to you guys before in a previous video is sometimes people will say, hey, I want to plug a number in and see what happens. And so if you plugged in a number of your choice, like let's say I decided I wanted to find out what happens if I plug in, let's say I plugged in the number 1. Now, if I plugged in 1, I'd get 3 times 1 squared, 27 times 1, and 60. This would be 1 squared is 1, 27, that's there, 80, I guess is 90. Now, that worked well, but keep in mind, if we use this factored form, it turns out to be far easier. Because if I plugged in 1 right here, 1 plus 5 is 6, and 1 plus 4 is 5, and so 3 times 6 is 18, and 18 times 5 is in fact 90. Or you could say 6 times 5 is 30, and 30 times 3 is also 90. It's just a nice, easy way to process things because factoring just means you're dealing with smaller bite-sized pieces as you go. Okay. Another principle that we often use when we deal with factoring is we really do not ever like this leading coefficient to be negative if we can avoid it. It just makes life a lot easier if it's not. So what I looked at is I decided I'm going to divide everything by that negative and the 2. Everybody here was even, but I'm going to take out the negative as well. And so I got negative 16, and a negative 126 divided by negative 2 is positive 63. Now, I didn't say anything in this top one because it was pretty straightforward. But if I have to multiply to get to positive 63, but add to get to negative 16, I would need both of my numbers to be negative. And I think 63 is one of those multiplication facts that most people know that that's 9 times 7. And so, and then we got x minus 9, and I got x minus 7. Sounds good. I'm doing a video for see ya. All right. Now, going to the next one. Oh my gosh, 200. That looks awful, right? But notice everybody here was divisible by 5. So if we divided everybody by 5, we're here. Now, again, when I look at 40, I think of the numbers like 2 times 20 or 8 times 5, but I don't see how the 6 is going to come into play. But I do know that since their product is negative and their sum is also negative, I have 2 numbers to multiply, but the larger of the 2 has to be negative. So I'm just going to go through all of the numbers that I could use to get 40. 1 goes in, 2 goes in, 3 does not, 4 does. 4 goes in 10 times, 5 goes in 8 times. This is literally my exhaustive list of everything that it can be. And I'm looking for somebody whose product is negative 40, but whose sum is negative 6. And we've got our values, x plus 4 and x minus 10. I've mentioned this in my class, but different people watch these things. So please understand that it doesn't matter what order you write these in. If you chose to write x minus 10 first and x plus 4 second, that's okay as well. But our whole goal is just to make things a little bit better. Okay, last one. Feels a little bit trivial, but I did want to address that. When I look at this, you look at it, they really don't have much in common, but I do not ever like to see that front term being negative. So what I'm going to do is I'm going to factor out effectively a -1. So if I factor out that negative, I look like that. Hopefully the bell isn't too loud, but maybe I'll go ahead and pause this for just a second. Okay, so let's finish that up now that our bell is rung. And so anyway, I asked this specific question for 2 reasons. The first of those reasons is to deal with the negative that was sitting in front, which is a little problematic. And second, to deal with the specifics of the number, because some of us are really, really good at our multiplication facts. And so I think, a lot of us would see, okay, I got a negative and a positive, so I need 1 negative and 1 positive. And the positive number has to be bigger. And so it's like, well, obviously -1 times 75 isn't going to work. And I know that a lot of people go, oh, well, I know that 75 is 3 times 25. That's pretty good. But buried inside the number 25, clearly the number 25 is itself divisible by 5. So that means I can also do a 5. So since 25 is divisible by 5, then 5 is also going to go into the number 75 because 25 divides in. And that was the number that I was looking for. And I figured most people probably didn't realize that 15 times 5 is 75. So sometimes you look at these numbers and you're like, how in the world am I going to get that guy? And that's because sometimes you just take a minute to write down all those possibilities. And we have my final answer. And again, if you're taking a test and you're wanting to make sure that you're 100% accurate, there's a couple things that you could do. The first is we could just check our answer by using the distributive property. So keep in mind, I'm going to go ahead and do a quick distribution just to make sure this worked. So the first thing I'm going to do is I'm going to distribute that x. That would be x squared. I'm going to distribute the x by the 15. Then I'm also going to distribute the -5 by the x and the -5 by the 15, which is -75. And then I'm going to distribute that negative through there. And you'll notice if we combine those terms, we have a -x squared. I'm running out of space to write this on the bottom of my paper, so I'm not going to finish. But you got a -x squared. We definitely have a -10x right here if we combine them, and a +75. So that's a good way to check our answer, is just to go ahead and take that minute to do the distributive property and make sure that they're appropriate. And if you had done the area model that we taught you, that would have checked it as well. So anyway, hopefully that was helpful. I'll see you back in class.